Hey guys, welcome to the second video of my interview prep series. In this video, I'm going to be solving the Fibonacci series problem. So what's the Fibonacci sequence? In a Fibonacci sequence, after the first two numbers that are 0 and 1, the rest of the values in the sequence are found by adding the last two elements in the sequence. So, for example, here the next number is going to be 8 plus 13. In the Fibonacci algorithm, we're going to be finding the nth value in the sequence. So now, let's solve a Fibonacci sequence together using recursion. So let's write the function. This is the wrapper function. So let's go through the steps that we described in the previous video. As you may remember, the first step was instantiating some variables. So in this case, we're going to instantiate the first variable. This variable is going to be an array that we're going to be calling it Fibonacci. In the comments next to this line, I'm just going to be writing that we are instantiating variables in this step. This is just good practice for me to remember what steps I need to take for solving recursion problems. So 0 and 1 are the first two numbers in the sequence. We're going to be pushing our values into this array as we compute them. At the very end, we want to return the nth Fibonacci number. So that'll be the next step for us to make sure that we return at the end of the function. In this example, we're returning the last item in the Fibonacci array. Again, I wrote in comments that this is returning statement step. So next we're going to start building the helper method. As you remember, we mentioned last time that a chunk of the work happens there. Here, we're calling the helper method searchFib. So let's talk a little about the parameters I and limit. This is the part that's a little tricky for me about recursion. These two are private parameters. So this is where we need to get creative about where to start from, what private parameter to introduce, and how to attack our problem. So in this example, we're going to be starting out at some initial point I, and then increment up until we reach a limit. So that's how we're coming up with I and limit, and that's why we're including those two variables. So the next thing that we need to do before we forget on this step is invoking the helper method outside of a function. So as you noticed, we set the starting point I to 2, and the limit is n. So the starting point is going to be incrementing up from 2 until it reaches the limit n. So next we need to come up with our base case. The base case here is when we have found the nth Fibonacci term. Therefore, if our pointer I that was counting up until it reaches a limit becomes greater than the limit, then we can return out. So now, what if we still haven't reached our base case? That's when we're actually calculating the Fibonacci series. So how did we calculate Fibonacci series? We calculated each new value in a Fibonacci series by summing the last two values in the series. So now if we want to write that in code language, we would do exactly that. We are going to be adding a new value to our Fibonacci array by summing the previous two values. So this line sums the previous two values together and adds that as a new item to the Fibonacci array. Now it's time to implement the recursive case itself, which means that it's time to call the search fib again. However, this time we need to increment the state variable I by 1. After all, state variable I was the one that was going to be incremented up until it reached a limit. So this is the recursive case. This is when the function calls itself. Therefore, search fib is the smaller version of the nth Fibonacci sequence problem. That's basically the definition of recursion. Okay, I know that can be a lot to take in, so let's draw things out. So recursion is actually a branching method. So let's draw the branches. In this example, we have a single recursion. That means that we're going to be having one single branch, and that's because search fib only calls upon itself once. In each case, we are going to be having a single recursion. Well, let's see if we can figure out what's the sixth Fibonacci number. Well, for calculating the sixth Fibonacci number, we're going to be starting from the second Fibonacci number. So the way the recursion is going to be working here is basically working its way up. So the second Fibonacci call is going to be calling the third one, then it's going to be calling the fourth one, fifth one, and sixth one. When I becomes equal to 6, then both I and n are going to be equal to 6. So what happens next is that in the next call, I is going to be equal to 7 and n is going to be equal to 6. Ta-da! We hit the base case. So when we hit the base case, the stack will start compiling one by one until it reaches the beginning of the call stack. At this point, search fib is complete, we're out of this function, and we're back to the wrapper function. So now the Fibonacci array has all the items in sequence. So now all we have to do is return the last item, which is the last index in the Fibonacci array. So that's it for a Fibonacci problem. I hope you guys learned a lot from this, and I will see you guys in the next problem solving session. Happy coding!